Okay, we are going to look some more questions. Now, if you look at question number 12, I don't know what's the issue there, and like less than more than 70% of you only got, sorry, less than 70% of you only got it right. No, sorry, less than 60% of you only got it right. So, what is the issue? There is the potential difference is 50, the separation is 5 millimeter. Perhaps you got confused and about the midway. So how many of you substituted for the separation half of 5 millimeter rather than 5 millimeter itself? I think that's the only mistake that you could commit there. Now we learned that if it's a uniform electric field, then wherever that particle is, whether it's here or here or here, midway, left, right, mid, center, italics, whatever the direction, the particle is going to experience the same force because the field strength is same everywhere. Okay, so even if it is midway, the electric field strength in this region is given by V over D for a uniform field between two plates. So 50 volts divided by 5 millimeter, not 2.5. That midway thing is there to confuse you, and don't be. So this would give you like 10 to the power 4 volt meter minus 1. Okay, so that's some answer. If you look at the answer, that is answer, there are two answers with that. Then the upper plate is positive 50 volts and lower is kept earth. So it is all the field lines begin from positive to negative, so plus to minus, so downwards. So the answer is A. 13th question, this is a nice question. So now the electric field line shows the direction in which a positive charge is going to move. Hence electrons which are negative charges will move in the opposite direction. Positive charges moves radially outward and the negative charges would move radially inward. So it's going to be either answer A or B. Now how are we going to determine the force? Now we learned that the force on the electron is going to be equal to force will be equal to EQ, right? So charge of the two electrons are same, so based on the electric field strength only, their forces are going to differ. Now if you look at X is closer, X is in a region where the lines are closer together. Here the lines are closer. But if I draw the same arc, an arc of same length here, the lines, I try to draw more or less the arc of same length, only one line is passing through, cutting through the dark. Here 4 lines are cutting through, and the lines are denser, they are closer together. Okay, and we learned that the gap between the electric field lines give the electric field strength. So closer lines means a greater strength. Hence X has a greater electric field, so X will experience a greater electric force. So magnitude of force on X is greater than force on Y, so answer B. Then question number 19. So I don't know what's the issue. First, again, the same idea. Maybe you are confused about how to determine plus and minus. So 1300 is more positive than 800. So the field lines always start from positive and ends in negative. So C goes off with that, D goes off with that. So they are in the other order. So C and D are obviously wrong. So only A and B satisfy the condition of field line direction being positive to negative. Now what is going to be the shape? Well, it's just directly from the nodes. You just So it will be parallel straight lines in the middle, and there's a bit of a curving at the ends, right? So yeah, so if you just follow that, uh, that would lead you to answer B. Okay, so answer B. Then question number 23. I don't know what's the issue. It's a negative charge. So as I said earlier, electric field lines are from positive to negative, denoting the direction in which a positive charge would move. This is an electron, so it would move the opposite way, so it would move downward. And it is a uniform electric field. That means the E is constant, and if E is constant, the force, electric force EQ, the Q is constant, so EQ is constant. So as far as the force is constant and electron's mass is constant, so F is equal to ma, so F constant, m constant implies A constant. So it moves downward with constant acceleration.